Hey, I saw you again. Good morning.
Good morning, and I've seen already a lot of the presentation which you've done in the morning. Very interesting stuff. So I'm really looking forward for our day 2. So on day 2, we have fixed wing aircraft, we have electric propulsion systems, and we have later on the infrastructure. So shall we make a little break, or shall we start the session right now?
Yeah, you can start it now. It's just 3 o'clock. And next is your turn. Please host the forum of the next stage. This is a very good forum. I hope we can meet next year face to face.
Yes, I'm really looking forward. Now I was traveling 3-4 times a year to China, and now since 2 years no travel. So I'm really looking forward. I'm jealous because I will especially miss the dinners where we talk and with all the participants. So definitely. Let's start the session now, and maybe later on when we see that we have a little time, we can talk a little bit also on the planning for next year.
Yeah.
Thank you very much.
Yeah. Thank you. Yeah. Next
Thank you. So I take over now. So what we will have as a first session is the session about electric propulsion systems. We will have Dongliang, sorry, he's the vice president of the Global Research Center at Wolong. We had Wolong already 1 or 2 times in our presentations, and Wolong is a large electric motor manufacturer. And I think he will maybe tell us much more about his company, and he will do what they are doing, how their path into electric aviation is. Then later on we have Royce, we have MGM Compro, we have the Helix, the prop manufacturer, and the TUM, the Munich University. So now the stage is yours. I see your slides are on. I switch off my screen and my mic. Thank you very much. Hello? Okay.
So good afternoon. I'd like to talk about the challenges and opportunities for the high intensity electric propulsion system. So the presentation would have been given by my colleague, so I'll give the presentation on behalf of him due to the pandemic. So there are 4 parts in my presentation. First, the development and the trends in the electric propulsion system. We have the dual carbon strategy. By 2024, the e-flight will have great increase by 50% in the demand. And worldwide, we have more than 240 types of the e-planes. And in China, we have the industrial UAV and also the flying cars. For the civil UAV parts, we are transforming to the 2B market. And for the vertical takeoff and flight, we have the new application scenario, and we are accelerating the commercialization of UAM with the pouring of a lot of investments. So this is a list of the pictures of the structures of the e-planes. In the civil aviation, we are also having the transformation with the electrification going on. So we will have the hybrid first, and then we will have the pure electric systems electric drive, then the technological requirement for the e-Aviation. First, in terms of the motors, we have the requirement for the performance. I think the first requirement is on the weight of the motor, and then the adaptability to the environment, and also the redundancy design. And for the vertical drive propellers, the intensity the power requirement is over 8,000 kilowatt, and the rotation speed is about 30 to 40,000. So we can compare the motor of the plane to the electric vehicles. The power intensity for the car is about 2 to 3. However, for the e-planes, the requirement is about 5 to 6. And then the driving control systems and the controllers. I think we have the same requirement for the controllers in terms of the intensity requirement. It should be over 16 kilowatt, and the output frequency should be 1500 hertz. And we also have the 6 to 30 kilowatt products in markets. On the right-hand side, we have the 100 kilowatt to 1 million watt power class. And for the controllers, and we also have a comparison between the planes and also the cars. And for the controllers of the plane, they do not have high requirement for the power. However, for the frequency, it should be doubled in terms of the plane. And the planes also have the demand of the heating. And we also have the other requirement for the technologies. For the technologies, on the right-hand side, we have the hybrid electric systems. And then the technology and the roadmap of my company. We take into account the certifications, and we look at the plans for the small, medium, and the big power electric drive systems. The power can be 4,000, 9,000, and 12,000, and even 30,000 kilowatt. And the voltage ranges from 100 to 200. And we use the topology of radial flux combined with outer rotor for the 100 voltage. And for the 300 voltage, we mainly use the radial flux. And we're transforming from IP23 to 65 in terms of the protection class. And we also have the nonsense FOC control and the high efficiency thermal design. In terms of the supply, we are transforming from the 45 kilowatt to the 500 kilowatt, and the voltage is 400 or 800. And for the propulsion roadmaps, we mainly use the radial flux. And then we also use the flecked copper wire winding. and the surface-mounted permanent magnet of Halbach. And we have the 125 kilowatt design model. In the middle, we have the 70 kilowatt design models. And for the medium power controllers, we use the carbon silicon components. For example, we have the pictures for the 100 kilowatt and the 70 kilowatt electric motors, and we have the test of the e-motors, and we are upgrading the controllers. Currently, in 2021's first half, we will have 200 kilowatt sample motor launched. And we also have the million watt for the motors. And for the technological roadmap, we mainly use the parallel of the medium power motor for the redundancies. And for the machines over the 1 million watt, we are making the technological preparations. The conduction motor also have the new requirement. And then about the conditions for the Wolong electric propulsion and some cases. Actually, we have a lot of business over the world, and we have 57 subsidiaries and 39 manufacturing base foundations. And for the products, our products are used in the home appliance
特种的大型电机
and also the industrial motors, the large size motors, and also the EV motors. And we have the output from the motors about 12.5 billion, the second largest in the world. And we are also working hard to become the largest one in terms of the motor. In 2018 October, we have the Global Center Research Institute focused on the technological development. And this is
上海研发中心和上虞研发中心
the global presence of the research center. We have the research center in Shanghai and Shanhui, Jiangxi province, and we also have the centers in Europe, Japan, and the US. And currently, we have 50 staff for technology domestically, and also for the e-motor products, for the certifications, we are developing on the e-propulsion systems. And this is our lab capacity. We have the supporters and different temperatures and also different humidities, and also the propeller supporters. And we are really honored to become a part of the technology setting committee of the e-flight. We have compiled 23 documents for the technology for e-flights. For example, the 1801 technological protocols. And we are also making new preparations for the new technological requirement of the e-flight. We have the small size production and also the large size manufacturing going forward. And those are the patents and also all our papers. We're also cooperating with the famous universities to have technological breakthroughs. And those are the application cases in recent 2 years. For the small power, we have the 9 to 15 kilowatt. We're cooperating with the manufacturers for the propellers test and also the trial flight and test flight. For the medium powers propulsion systems, we have the research efforts in the 125 kilowatt projects, and we improve the output power to the 175 kilowatt, and the power intensity can be 3.4 kilowatt every kilograms. And in the Q1 2022, we will have the in-house test of the control and the motor, and also the combined test with the propellers. And also for the picture in the left side, this is the start and launch integrated machine. And in Shangyu plant in October, we have completed the test of the 70 kilowatt of 36,000 RPM. As mentioned, the largest power intensity can be over 10 kilowatt every kilogram.
2年我们也形成了做好。
We also have the strategic cooperation in recent 2 years. In the end of 2018, we're cooperating with GGC for the MOU signing. And last year, the pandemic halted the projects, but our own projects domestically has been well underway. We are honored to have the cooperation with Wanfeng and Wofei Changhong. And we are cooperating with other manufacturers domestically.
This is the headquarters building of ours in Shanghai, but it is still in construction period. I welcome all of you to visit the headquarters building once it's completed. Thank you.
Thank you very much, and very interesting presentation. And we see that large companies like Wolong getting more and more into the electric aviation. And electric aviation is really a field where now more and more large companies are looking into it. I see my next speaker, Matheu Parr from Rolls-Royce. He already is online and he is getting ready to speak. So Rolls-Royce, as you all know, had in 2019 taken over the electric aircraft activities from Siemens, and since then made large progress. So welcome, Matheu.
Thank you very much for having me, Willi.
I hear you very weak only. Wait, let me. Okay, now it's better. Yeah, it's because I was on translation mode, but you don't speak Chinese, so I have you in English. And so yeah, we have like, this forum is still COVID time, so we have a separation in the locations. Most of the guests are in China. I'm sitting in Germany. You're sitting in UK. Actually, is this correct?
Yes, that's right, Willi.
Okay, so yeah, that's one of the reasons also why I would first share my screen and present the video, because there we would have a little bit better quality. And then as you will continue, if there is an issue with the presentation, I also have the presentation open here and I can continue with the presentation. That's not a problem at all. So let's start the very nice video. I share my screen. Here we go. You're right. And now we have to get going.
This project is an attempt to go break the world electric speed record.
If you put 550 horsepower in a little airplane like this, it's going to go like the clappers. And it does.
It's a great aeroplane to go and break records with, but also to prove the future and the next steps for electric aviation.
The key thing about breaking the record is about demonstrating how fast this technology is going, and therefore how soon it's going to be in all our lives. This technology offers us the opportunities to start travelling in a really net zero way.
When you look at the team and the interaction across the whole board, the engineers, project management, the ATI, the government, I've never seen a team come together and achieve what this team has done.
We've broken a record that already existed, but crucially, we've broken it by a phenomenal amount. I think it's clearly demonstrating that we're getting into the third age of aviation.
Electric aviation is absolutely and utterly here to stay.
So very nice video. This, I think, is your presentation, and I can leave it on like you tell me what you prefer. Just have to go to the full screen mode. So you prefer that I play the presentation, or you want to play yours?
As we have it on the screen, if you could play it, that would be really helpful.
Perfect.
Thank you. And then if we could just go to the third slide, please, Willi, that shows just after the video. Thank you. This one's perfect.
Perfect.
So good afternoon, everyone. Thank you so much for the opportunity to talk to you today. I'm Matheu Parr. I'm the customer director at Rolls-Royce Electrical. As Willi described, we've been investing in electrical capability for more than a decade now within Rolls-Royce across the marine and land markets. And with the acquisition of Siemens e-Aircraft in 2019, we've now put together a world-class team to go and focus on the advanced air mobility markets. So a team that is focusing on urban air mobility and regional air mobility opportunities. I have had the great privilege for the past few years as well to be leading the project that you saw in the video, a project to build the world's fastest electric aircraft. And we hope this is a project that inspires people, a project that shows what electrical technology is able to achieve today by breaking the record, but not just breaking the record by maybe 5, maybe 10 miles an hour, but breaking it by more than 130 miles an hour and showing just how quickly the technology is moving forwards. But actually, crucially, we undertook this activity to go away and understand what was state of the art in the automotive industry and understand the baseline technology that was available, and also work with certification authorities to start to increase their awareness of the technology, in that we would need to have their support to fly the aircraft. And the aircraft has now flown more than 30 times. It's covered more than 2,200 kilometers during its flight test program. But I think crucially for Rolls-Royce, this is only one small part of what we are undertaking. We have actually flown more than 1,500 missions with electric aircraft. We have a really strong capability, and we now look to bring that into the advanced air mobility market. Could we go to the next slide, please? Our focus is to bring full electric propulsion systems through into the advanced air mobility market. So that is sub-megawatt and megawatt electrical machines. So the motors to directly drive propellers, the controls and power electronics for those motors. And we're looking at as integrated a package as possible to optimize on power density, as we saw in the presentation from Wolong just before. We will offer a Rolls-Royce battery solution, so we're investing in energy storage, and we also offer the complete electric power distribution system. So everything you need essentially to go from energy through to propeller will be in our portfolio to work with our customers. And we do this all with a strong focus on fault-tolerant, fail-safe, and flight-critical systems. So a strong focus on systems that we know through our aviation heritage are going to be required by our customers, by the regulatory bodies, to ensure that your aircraft has the right technology to allow it to progress into market as fast as possible. Thank you. Could we do the next slide? Thank you. As I highlighted before, we're going to focus on 3 key markets. So we're going to focus on the small propeller market, which we describe as the sort of 1 to 4 seat GA, general aviation market. Here, we're really interested and excited by the trainer market. We think it offers some real opportunities for electric upgrades or new full electric aircraft. We are focusing on the urban air mobility market. So in here, the vertical takeoff and landing, all electric solutions, we think are very possible in 2025. And I'll talk a little bit more about our key customer at the moment here, vertical, as we go forwards. But we're not only focused on all electric, we are also generating hybrid solutions around a gas turbine as well. And then we also look into the commuter market, so the fixed wing Part 23 small commuter aircraft they're generally used for moving between regional airports. We think there is possibility to substantially change the way we travel with the electrification of these platforms as well. Next slide, please. So just running through some of the projects that I hope you'll see from Rolls-Royce. And if you haven't, you'll definitely see more of in the upcoming months. This is the project we are running in Italy with Tecnam called H3PS. This is a hybrid aircraft where we are taking a Rotax combustion engine. We've attached a small 30 kilowatt motor to that Rotax engine that provides the boost power necessary for takeoff, go around, for key flight maneuvers, but essentially allows the Rotax to run at its most optimum point and improve the fuel efficiency of the aircraft, and equally, of course, improve the range. There is a battery on board this aircraft, of course, to work with the electric motor, and the battery can be charged in flight off the Rotax as required by the operator. We've completed ground tests of this aircraft. Hopefully it will be up and flying in the next few weeks, and you'll have an opportunity to see some footage of this aircraft flying around the skies of Italy very soon. Next slide, please. We're very proud to be working with Vertical Aerospace in the UK on their urban air mobility platform, the VAX4. This aircraft targets certification 2024, and on this aircraft, Rolls-Royce will be providing the electrical propulsion motors, the power electronics, and the batteries. So apologies, the electric power distribution system. Within that package, we're essentially responsible for the delivery of all thrust off the aircraft and work very closely with our launch urban air mobility customer vertical. However, it is our intent to work with as many urban air mobility platforms as possible. We think our 100 kilowatt lift motor that we are designing for this market segment is highly attractive, offers the best power density and reliability, and we are very interested to talk to all airframers who are pursuing aircraft in this segment. I think the key thing about this market is the range that is trying to be undertaken. The 120-mile range that is forecast by Vertical, we think is highly credible for what electric aviation is able to offer today, and really sets this aircraft apart from some of the other concepts that are pursuing longer ranges where we struggle to trace through the battery calculations, etc., and demonstrate that's viable. We're really interested in working with the customers who've got a lot of sort of deep analysis in their market routes and are able to identify opportunities within this range. Thanks, Willi. The Tecnam P-Volt is another program being run with Tecnam in Italy. It's a 9-seater commuter aircraft. And here in this opportunity, Rolls-Royce is delivering the motors, the power electronics, and the battery. So that this aircraft will have circa 300 kilowatt electric motors on board to drive the thrust, direct drive to the propeller. We integrate all the power electronics into the motor to give a very good packaging, as power dense as possible. And then this will be the first aircraft to also have a Rolls-Royce battery solution on board. The aircraft will have a range of around 100 nautical miles in 2025. But as battery technology improves, we're looking to extend that range out to about 150 nautical miles by 2028, 2030. We see lots of excitement in the market for this aircraft, and particularly from airlines who want to learn how to operate an electric aircraft, who have island hopping or short city routes where that range works for them, and gives that, crucially, it gives them an opportunity to start to understand operation, maintenance, pilot training. How do you start to understand an electric aircraft within your fleet? Thank you, Willi. For Rolls-Royce, however, when we look at this market, we recognize that the electric propulsion system is only one component of the overall solution. We need to also think about how are we going to charge these aircraft? How are we going to ensure the fast turnaround times that we expect our customers to require to get the utilization of the air asset up as high as possible? We also recognize there are limitations in regional airfields today in terms of electrical infrastructure. There may not be enough energy coming into the sites to allow for all the aircraft that are planned to be charged fast enough and continue operations. We've therefore invested in a microgrid approach. So working with Rolls-Royce Power Systems in the Rolls-Royce group, we have developed a containerized solution that allows you to install either batteries or hydrogen fuel cells on site, together with the charging infrastructure necessary to keep the aircraft in the air. We think this offers some fantastic benefits in terms of being able to plan and optimize around the energy cost, to be able to demonstrate to customers that as well as flying in a zero emission all electric aircraft, you are also charging that aircraft in a net zero manner. If we have any issues with quality of supply at the site, that can be assured through the fact that we're bringing dedicated power supply through. And where this is used in combination with renewables, with solar or wind, it also offers a regional airport the opportunity to start to generate electricity and then sell it into the grid to generate new revenue streams. So very much from Rolls-Royce, it's an approach not only on the electric propulsion system to go on board the aircraft, but the full infrastructure that you require through to maintenance, through to your aftermarket services to actually operate the aircraft as well. Next slide, please. I mentioned at the beginning as well, we are not just focused on all electric solutions, we are also focused on hybrid electric solutions as well. And we are currently investing in a turbo generator demonstrator where we are designing, we believe for the first time, a gas turbine together with electrical machine specifically for the urban air mobility and the regional air mobility market segment. So we're taking in requirements from customers. What do they see as the turbo generator requirement in their market segment, and feeding that into a design program. The gas turbine itself, we believe, is targeting market leading power density at 4 kilowatts per kilogram for the full integrated system. And we were going to ensure that the machine is capable of running on sustainable aviation fuels and also have a provision for burning hydrogen, should that be the decision that the platformer wishes to take. Of course, this machine is also ideally suited as an APU in larger aircraft, and we're engaging with customers right now to get more about their requirements and be able to feed them in to our design activity. Next slide, please, Willi. So thank you so much for your time and for your attention this morning. Willi, I'm happy to answer any questions now, or we have a specific forum, but I appreciate the time to present. That's all the material from Rolls-Royce.
I'm sorry, I had to unmute myself. Yes, thank you very much, Matheu. And yes, we would have the questions like we always do at the end of the session, so that also people can have questions among each other. So even the presenters, sometimes we had a really nice discussion. So thank you very much, Matheu. And I welcome now Jakub from MGM Compro. If you unmute your mic, yes. And if you say a word, because then you should appear right on the screen. And I think you will share your screen. I think that's the best way for the presentation. So Jakub is Director of Communications at, you're a little bit weak, so if you could speak a little bit louder would be great. And Jakub is at MGM Compro, a company which has been presenting at the forum already several times, and which has also, I think, many or more electric projects than probably any other company in the world. So I'm happy to hear your latest developments. And if you could share your screen, we can see if it works, and then I can mute and disappear.
Yeah, Willi, please, if you can share my presentation.
Okay, I also can do. Wait, then I have to check MGM Compro and open it. 1 second. This out of your and oops, where is my? There we have MGM Compro. It's opening. Computers are always slow when they now here we are, and we make it there, and I do it full screen, and then I share my screen, and I share the right screen. You should see it right now.
Yeah, thank you very much, Willi, and thank you also for the opportunity to be the part of this great event. It's been the second year, so we try to follow with the update on what's going on right now in MGM Compro. There's a slight change right at the beginning because Martin Wolski, our managing director, couldn't attend because he got stuck at the airport. So it's going to be my turn today to lead you through. Next slide, Willi, please. So very briefly, who we are and what we or how we contribute to the e-aviation market in general. We are the designers, developers, and also manufacturers of the specialty electronics, and the highest value added we bring to the market is the complex electric propulsion systems. Right now, we have system ready from 10 to 100 kilowatts, and right now developing the system of 400 kilowatts on the shaft I'm going to be talking about later in the presentation. So we are based in the Czech Republic with our R&D facilities and also production facilities here. We are on the market from 1990, so it's been more than 30 years, and right now we are a team of 50 professionals, mainly electrical and electromechanical engineers. We export to more than 15 countries, so we're quite global in our activities, and this is the quality it goes with it. So top-rated supplier and quality management is the key for us. Willi, please, next slide. So we can have a look briefly at the product portfolio. contributing. It started in the early 90s with the development and production of electronic speech controllers. So we can say that it's our core business. And then it followed with the electric motors and the battery systems. It started with BMS, and then the customers asked us more and more to design the overall battery system. Right now, it's quite complex, mainly for the UAV projects we're in right now. So altogether, it makes a complex portfolio. And as I said, the performance range is rising in the last 2 years. We are, let's say, above 800 kilowatts in the projects which are in the development stage. So, Willi, please, next slide. So here we can have a look at the different fields of e-aviation we're active in. So right now, very famous field, the eVTOLs, where maybe more than 150 projects are active. So MGM Compro is running 15 projects here, where the power, the motor ranges from 20 to 80 kilowatts in general. We can say that this is really a forefront of the e-aviation technology, and all the major players are active here. So we try to also catch up with them and come up with some complex solutions of the e-propulsion systems. The field where it started, I would say, and it was in 2011 with the first Airbus projects of electric aircraft. It's a light sport aircraft, or we can say the UL 600 kilogram category, where we have already 21 already flying projects. Some of them are going towards the zero production. Some of them already quit, but this was a field where we gained a lot of knowledge and also learned more about the certification and the let's say approach how to develop the electric propulsion from the scratch. So then the UAVs also very I would say popular category here at MGM Compro. I would call it the key player in 2021 with a lot of new projects coming in, not just in the first stages, but also in the, let's say, zero production. And I'm going to talk about the particular projects further in the presentation. Self-launching gliders, also very great fit for the e-propulsion systems. Right now, 11 running projects, out of which 3 are already in a serial production. And the biggest thing in the end, MGM Compro has started this year the development project of the electric propulsion system of 400 kilowatt, which should be suitable for smaller commuter class aircraft, and which goes under the CS21 certification class. So please, Willi, next slide. And I'm going to talk about this big project as a first. It started in May this year, and the greatest thing on that, from our point of view, is that we have a very close cooperation with Vector, the airframer, which is just 20 kilometers from us. So we took advantage of this regional, let's say, boundaries that we can use their aircraft, the EV55, as a testing lab for this drive unit, and this helps us to get much faster towards the, let's say, certifications which we would like to go through after finalizing this project in 2023. So please, next slide. This is, I would say, one of the biggest projects we work on in the field of eVTOLs. This is XDA aircraft 600. This is very, let's say, ambitious project, large. There's also close cooperation with Honeywell, and the hybrid electric propulsion systems should include 4 electric motors, which is our part. So we deliver the motor controllers plus electric motors with a very sophisticated control system and controller firmware, which is very customized for this particular purpose. So next slide, please. Phoenix project, one of let's say our favorite projects in the UL 600 kilogram class aircraft. This is a nice 2-seater. The development started in 2018, and the aircraft was flying the same year. It's maiden flight right now. The aircraft and the overall system is ready for the serial production. Yeah. So here one back, please. Yeah, the graph, please. Next one. Yeah. Thank you, Willi. This is one from another project from the category of UAVs, and the one which is already finished the research and development phase and is already in the serial production. I think that this is one of the, let's say, most advanced projects we went through, and we contribute with the overall electric propulsion system, including the battery system. Next slide, please, Willi. Yeah, from the category of self-launching gliders, I think that the one which is the most advanced from our point of view is definitely the GT gliders, the 14SE Velo. Here is very important to say that it was a development from the scratch, and we developed all together with our Polish partner the so-called retractable electric self-launching systems. As you can see on the picture in the background, you can retract the motor when you need it, and then for the sailing you can hide it in the fuselage so that the aerodynamics is not influenced by the pylon. So next slide, Willi, please. So yeah, but here you can see very briefly some of our references we have, so that you can see that MGM Compro works both with the big ones, with the big players, big research institutes, and also universities, but also with the startup companies and the companies who has some special idea, to come up with. Next slide, Willi, please. Yeah, and that's a wrap up already. So what we learned from the projects we're going through, let's say last 10 years, where the e-Aviation is uprising, is that the most important thing is to test from the beginning, which is sometimes very underestimated by some of our partners, and mainly by the partners who are not existing anymore, if I can tell this. And this leads me also to the idea that the next presenter, Florian from the Technical University in Munich, is our partner who went through the, let's say, complex testing process at MGM Compro. And you can see maybe a bit more hands-on how it looks like to develop a project from the scratch and then join Compro. So thank you very much, Willi, for the opportunity to be here, and thanks to the audience for their attention.
Audio, video. Hey, thank you, Jakub. And before we come to the next speaker, I can say something which you didn't mention, but perhaps we can mention this in the discussion later, that you're also involved in one project in which one of your cooperation partners, Helix, a prop manufacturer, is also involved. So this is our next speaker, Richard Krüger-Sprengel. So Richard, if you can unmute your, I see you've done. So hello, Richard, good morning.
Yeah, good morning, ni hao. I'm pleased to be invited to tell some words about the propeller design.
Yeah, we see that you have your work in your back, standing in your back, all different kind of propellers. And because we always talk about the propulsion system, but that's not only for most of the aircraft, just the motor, the battery, the controllers. The prop does a very, very important thing, and you will tell us, I think, that how different this is also from at electric propulsions and from other propulsion where you come from. So may you try to share your screen, and if it works, I mute and leave. Yeah, or shall I play the video?
Let's see.
Now it's perfect. It's there. So I go off and leave you the stage. Thank you very much.
Yeah, my attempt is a bit shorter and less proposing our own company. It is more in the way that I try to give you some information of what is important from point of view of propeller manufacturers for electric flight aircraft designers when they think about a propeller and what to take care. Before these few pictures, what Helix is producing, it is traditionally coming from the light sport aviation, maybe similar like many other manufacturers of eVTOLs, is a powered paraglider, which gives us a chance to produce thousands of propellers. In fact, we do every day 40 propellers sent out. But from company revenue and company ongoing, it is of course also the heavier aircraft, LSA or the 600 kilogram class, which takes us quite a lot of propellers. Gyrocopter, something lately invented, but very commonly used. Upcoming is, of course, the eVTOL, the multicopters. You all know about this Volocopter project, which I supported from the beginning and tried to push in the biggest possible dimension. Nowadays, I see that they are quite far in this business. The majority of eVTOL manufacturers found out that it is important to have eVTOLs flying straight forward with a separate lift unit. This project, like you maybe remember from yesterday, from eMagic, from MCAR Technology, is one of those which is for me a good example to tell about technical details. Of course, I know we have quite a lot of other applications, maybe like UAVs for military usage or civil usage. But characteristic for the problematic, or let's say for the unknown issues which exist around the propeller, the vertical flying is difficult. It is difficult because it is not well experienced. It is new that we try to control aircraft via propeller speed, and additional caused by the few energy which we can take up in the air. It is absolutely essential to have the best efficiency and the properties during the lift phase, but also during the transition to go forward. And these lead into very special propellers, which are maybe very slim or have a very special design. And what we found out is that calculation is the basis for the new propeller. It is, of course, very important to start with the correct first propeller, but afterwards the simulation end up a little bit in the next prototype. We will need to make a master plan for different iterations, meaning a variation of chord lengths, of diameter, of profile arrangement. So the geometry of one best propeller comes from an evolution of many propellers which we needed to produce before. Typical one was that we used for the eMagic 15 different propellers to really find out the best one where it is sure that nobody on the world will find easily for same application the better propeller. It is not the rule that we always produce so many for one application, but in this case, it was necessary to push our skills in this direction. We do a lot of practice testing. Of course, the closer to the product, to the application, the better the results and the clearer the advantage. But it starts mostly on ground. We let run our test bench beside the factory quite often to find out the curves from all propellers right away. Another issue is what could we do as a propeller manufacturer or an aircraft designer to make things better? One of these things is to optimize the behavior of the propeller or the complete aircraft during transition. After takeoff, acceleration forward is relatively easy, but it is a curious thing to start propellers which were aligned during the cruise flight into action to transit into slowly flying, or let's say stop the aircraft right up in the air. Because the airflow from the side to the propeller does not hurt much the propeller, but oscillation, vibrations go into the structure of aircraft. And as long as the aircraft is a UAV, maybe nobody realizes this fact. But I'm quite sure that in case passengers fly inside the eVTOL, which transits from fast flying to slowly flying, they might be a bit worried by the vibrations they observe. We start now to find the ways how to optimize to make it smoothly running, or at least as best as possible. One of these ideas we try to test now with cooperation partners, TU Munich, is to find out the difference of the V setting at a rotor. Similar like helicopters flying also with some slightly angle of blade axis to the rotor disc. We created propellers with 4-degree V setting and try out how they behave. They have the interesting effect that from 0 RPM to max RPM under full load, statically, they do not change the ring in which the blade tip is spinning. So they have good chance to be on the observation of the tip running around the engine. The propeller is statically in the same position. Just by the blowing air, the propeller will move. But it is expected less than a standard propeller turning in its rotor disc. We started these trials, but they were not out. And I think my colleague Florian will tell you much more about this in the following presentation. Another issue related to the technology of propeller design is, in case you design eVTOLs, you must think about efficiency, the maximum lift you can get out of the weight of the material you invest. Nearly all aircraft manufacturers requested us to receive the most lightweight propeller ever, because every gram is difficult to bring up in the air. And from my point of view, things changed a little bit since we analyzed not only geometry iterations, we analyzed also what kind of structure can we give the same geometry to modify the behavior. And what we found out is we can create propellers with nearly the same geometry in the way that they consume the same energy during its running, but having an efficiency with a wide difference from what we expected. It is up to, let's say, 10%, 12%, which we can get more lift from the same energy we invest by creating a propeller around about 30% heavier, meaning we invest more in stiffness, which is the first clue. And the second one is to modify the fiber layup in the propeller in the way that it is best. Therefore, we left long ago the idea to use just carbon fiber for this issue. It is mostly ultra-high modulus carbon fiber, which is much more stiff than standard carbon, and let us realize structures helping the propeller business very, very much. In the end, it is important to think about who creates the eVTOL rotors. Me, as a realistic manufacturer selling thousands of propellers, I know that the price must be correct for the correct serial product. But now nearly all eVTOL manufacturers are in the phase of creating the product, modifying, testing, and try to be the best and fastest presenting the good solution for future public. And in this phase, it is, of course, my suggestion to use the company Helix as a research and development partner, maybe with the clue that we are EASA certified and can present you the prototype where the permit to fly is probably easier to get. But with view on the market, we see that in general aviation, all aircraft manufacturers trust in their suppliers to receive the correct developed propeller, because they separate their business and the propeller business. In helicopter market, which is also close to e-flight, it is in the way that the technology is so important and so difficult and so special that from my knowing, 100% of the helicopter manufacturers produce their own rotors because it's their core technology. And they produce, of course, in serial numbers. At automotive company, where the intention to get the big revenue also in eVTOL flying, you see that the car manufacturers trust for sure in their suppliers. Nobody would create its own tires, even when they were new and have very special effects. They come from suppliers. And at eVTOL, I think it is reasonable to make development and also the serial production given by specialists taking care of the propeller issue, which is also from certification side foreseen from the EASA at least, and also for FAA. I know that all aircraft manufacturers have their sorrow about this, but at least Helix is doing only propellers and nothing else, meaning your intellectual property is safe at us, but we need to make good contracts to be sure about it. The complexity of this matter is so difficult that I would not think that it is good to charge only the eVTOL manufacturer with this propeller matter. Okay, the iterations is one thing. I founded the company Helix to be capable to do thousands of iterations with few costs. And we have more than 1,200 molds with different propellers produced daily. And I think we can add some more thousands to help the eVTOL business. Experience, yes, we have 30 years, but I would think it is clear that the manufacturer of propellers has experience. Otherwise, he could not succeed. And I think really you will find the way, as you did long years before, to do everything faster. You accelerate the eVTOL business, and I hope I could give you some few informations which can help the public.
Okay. Richard, what is last slide of your presentation?
Yes.
Okay, thank you very much for the presentation. That's always the interesting thing which we have there in the forum. We have total different people, so people much more technical in their presentation, other people being very interested, and other people from research, which will be our last speaker, which is Florian Holzapfel, whom you know. Florian, if you could switch on your camera, would be great. Yes, here he is. And there is also our co-host, my cooperation partner in China, Ms. Chen. As you have been from the beginning, always in our presentations, Patty would like to say hello to you.
And I'm happy to see her again.
We can't hear you, but if you can unmute Ms. Chen, Xin. Yeah. Now, if you say something, Patty. No. No. Do you hear anything?
No,
we don't hear. Hello.
Hello.
Hello. Yes, now we hear you.
Okay, okay. I just want to say hello for Florian, or my good friend.
And it's very nice to see you again.
Yes, thank you.
Okay, so you continue, okay?
And hopefully next year we can meet in person.
And again to Richard, yes, we will have some Q&As question in the session afterwards. Florian is with the forum since the beginning, and he is giving me a lot of motivation and he's also doing a lot of loops and rolls, as we see in his simulator in the background. And yeah, I'm happy to hear what you tell us this time, Florian, and then we talk later in the Q&A session. Flori, perhaps share your screen.
Yes, I would share my screen, so please tell me if the presentation is visible.
It's fine. Screen is fine, and I'm off.
Perfect. So Willi told me only to talk between 5 and 10 minutes, and my original expectation was that I would be squeezed between Jakub from MGM and Richard, because I want to echo something that Jakub was saying in his MGM presentation, that it's very important to test very early. And he also highlighted the collaboration between academia, startups, and small and medium-sized enterprises. And this is something which I also would like to promote. And for me, at this point, I want to make a short commercial for MGM on the one side and Helix on the other side. So we are doing flight controls for 3 different eVTOLs, for 3 different undisclosed companies. And we found out that they all 3 use propellers from Helix. And also MGM is a very well-known company in the field. And what I would like to encourage the people building airplanes is that they don't see companies like MGM or Helix as pure suppliers. These companies are true partners because they have a lot of competence. And if you design your own system in your closed room and then go there and say, build me this motor controller and build me this propeller, this is really bullshit, because if you go to those companies before, then you will find trustful and very competent partners who give you directions already when you start designing, so that in the end, what you produce will be much, much better. And in my presentation today, I quickly want to highlight this year nothing about flight controls, but some things about testing, basically, which we are currently doing in order to get a good feeling for high-speed forward flight with multicopters and transition eVTOLs. And of course, no need to mention in this picture here, you see our testing truck that was provided by one of our startup partners. And the motors are, of course, controlled by MGM motor controllers. The batteries from MGM and the propellers, no need to mention, are from Helix. Just one slide about my institute. So the important thing which I always want to highlight is that we are not about fundamental research, but we started to do a lot of flight testing on fixed wing aircraft that owned us projects from companies. Then we also added to some international projects. We are working on UAVs where we provided the full flight control system. We also make strange things like own missiles, which we fly and control. We also add to small UAVs internationally, a helicopter currently 600 kilogram, which we are supposed to fly unmanned. And of course, the big business is the eVTOLs, and with the eVTOLs, it's the most exciting things, but the companies also don't want that you talk about them. And the reason why we entered the business once again, we did a lot of flight control for wing-borne aircraft. We did flight controls for multicopters, and beyond that, we had to deal with safety and certification aspects. And if you see this as a serious business, then especially this last row is very important. And when you bring wing-borne and multicopter together, you have transition vehicles already. And when you add the certification aspect, you end up with all the spices which you need for the eVTOLs. And our typical tasks as institute in industrial projects is to do modeling and simulation upfront, and then later when the system is flying, system identification. Then another thing we do, of course, is ground tests and hardware-in-the-loop tests of components. So you have a high confidence and a high maturity before you go really flying. Then when it comes to system architectures, we deal with redundancy management and with the safety analysis of the systems. Then, of course, our core discipline to provide flight control functions for the nominal flight control system, but also for emergency controls. And beyond that, of course, as already addressed, hardware in the loop simulations, complete setups, and where it's also important to mention that it's not like a university experimental playground, but we do this together with companies that are providing the hardware in the loop systems for the certification of large Part 25 or fighter airplanes. And then, of course, we are dealing with certification aspects where we are talking to both EASA, then in Germany also DULF and the FAA in the United States, and where we are contributing to working groups within the ASTM F44 and the Euro CAE Working Group 112. And for today's statement, it's a little bit about looking at propulsive and aerodynamic effects, where at my institute, it's not about doing complex CFD calculations, which are very important and make sense. But what we try to do is we try to make first principle models with a low number of parameters where they later, when you do simple tests and measurements, it will be much easier to match them with the measurements to have verified and validated models, especially for developing flight controls and producing evidence like, for example, for load calculation. And beyond the normal propeller aerodynamics, of course, you have to look at the interactions with the airframes, at the interactions between propellers mutually, then very important, the aeroelasticity. And this is something which Richard already addressed, the very high vibration level, which you get in strong slipstream conditions. Then basically the transient inflow dynamics. And of course, for hovering systems, it does not help for transition vehicles if you only have aerodynamics between 5 and 20 degrees angle of attack. And as I said, one of our big assets is our new test truck, which we established together with a new startup company. We founded together with an investor to build a new, basically, eVTOL aircraft. And as I mentioned again, motors, motor controllers, electric systems from MGM, where we profit a lot from the great know-how and also the patience and the consulting with MGM, and the same holds for the propellers. So I don't know, the video is not too spectacular, but one interesting thing is, I think you can't hear the sound, but one of the really interesting points is that basically as the dynamic pressure builds up, the noise level is really tremendously increasing. And this is a proof for the fact that basically also the vibration level gets high, and we of course also measure the vibrations via IMU, so we can have a close look at the vibration spectra. But one of the big things which I really want to highlight, because it's something which you don't see if you fly with small subscale models, and which is tremendously getting worse if you go towards large systems, is the pitching moments you get when the airspeed is increasing, when you have a slipstream condition. So when basically the propeller gets the airflow from the side. And so basically this would be for a vehicle with 12 propellers, and you see on one propeller only you already get pitching up moments in an order of magnitude of 100 Newton meters. And I know from many eVTOL companies that are not really too much admitting it in the public, but which are having severe problems due to these effects. And you know, all these challenges are not really bad, because if you address them properly, they can be overcome. And again, for example, this is a point where I'm very happy that, for example, with Helix, we have an open and a serious partner, so we can talk about these things. Then the other thing is with the first principle model, for example, a very simple model. So to get the easy match later with the measurements, we produced this curve before we had the measurements. And so the interesting point we see here is that for a large range of RPM, the match is quite good. And for the higher RPM, we are now investigating which Mach number correction and which elasticity correction we would have to put into the model to improve the match also towards a higher RPM. And what we were especially proud of, we computed the pitching moment before we did measurements with our truck. And then we did the measurements with our truck. And so what you can see here is that the predictions and the measurements match very well, which of course gives a lot of confidence in the approach. But the important thing is that you're not only doing this for components, but that you're also doing it on an aircraft level. So as soon as you have flight test data, then of course you try to match the aerodynamic data of the real aircraft. And the challenge here is because of the vibration that the recorded data, especially in transition, is very, very noisy. And so I would say that we are now at a very mature stage when it comes to this parameter estimation. And just to highlight it here, for example, for the real transition of a 400 kilogram eVTOL, you see the raw data and then basically the results, which we got after smoothing. And based on this, we can make a really high fidelity aerodynamic model, which allows you to produce a flight controller with a very high confidence. And another speciality is that we do not only reproduce the aerodynamics, but as it's very important for these vehicles, we also actively reproduce the vibration spectrum, so that also in simulation, we cannot only produce fake vibrations, but we can make sure that our simulated vibration spectra really in the frequency domain perfectly match the actually measured vibration spectra. And by that, of course, we get a lot of advantage when it comes about designing noise filters and sensor filters for the flight controller. But it's also helpful for other issues, like, for example, estimating the impact of the vibrations to the loads. I will have another slide on loads later. One of the big points is, and this is one of the cool things for us, the eVTOLs are quite new, and so there is still a lot of uncertainty involved. And so it's very important that you don't pretend you would know everything exactly, but you actively have to manage the uncertainty. And this, of course, means that for all the parameters, we are not saying, okay, this parameter has a fixed value, but for all parameters, we assume that they are uncertain and therefore have a certain probability distribution. And for that, we developed a new methodology that didn't exist before. And of course, it wouldn't help you to have an uncertain model if you would not carry that on to the analysis. And so therefore, basically, we can then also do all our analysis probabilistic. What does it mean? It means if we have certain requirements, then we can state what is the probability at which a requirement is violated at a certain point of the envelope. And this helps you very much to control your safety and, for example, define what would be your first flight envelope, how are you slowly expanding the envelope, what are the points where you can test with high confidence, and what are the points where you have to be a little more cautious. And then, as already addressed, a very important other new thing now for the eVTOLs is the dynamic loads, which are also not too important for small eVTOLs, but they start to matter for large vehicles, because on the one hand side, there is an additional time delay between basically your command to one of the propellers to make a control moment. And so not for, if you make a controller that should just fly fine, it doesn't hurt you a lot. But if you move towards bringing stability margin proofs for certification, these elastic delays start to hurt you. And so the earlier you account for them, basically, the more realistic you can work, and the higher the confidence that you can prove sufficient stability margins. And then, of course, another important thing with the pitch-up moments and everything, the eVTOLs produce load cases which are not known from classic airplanes, and which you should really also address by calculation, because the results do not necessarily match the the intuitive expectations. And finally, of course, you have to continue your modeling towards all the relevant subsystems. And this closes then again the loop with MGM Compro, because of course you also need high quality battery models where you want that your simulation model basically matches what you measure. And so you take electric loads, for example, to stress single battery cells and so on. So you make a thermal model, you make an electric model and so on. And our next step, which we want to do, is that we want to now, within the next couple of weeks, do full closed loop mission simulation, hardware in the loop for hover flights with the real propellers and the real electrical system in the loop. So we can check if for the whole closed loop, our models are correct. And the whole purpose this serves is to be sure that when we fly for the first time with the real aircraft, that everything behaves as expected. And so on this path, we are very proud to collaborate with great startup companies. And we are very happy and proud that we have strong partners like Helix and MGM, where we do not only profit from the products, but where on the same level we profit from their great competence and their active assistance. And so at this point, I want to thank our partners, and I want to thank the audience for the attention. And finally, thank you to Willi and Chen and the crew of the eFlight Forum for giving me the opportunity to present again. Thank you.
Thank you, Florian. And thank you very much for, like always, a very interesting presentation. Please stay on screen. And please, the other speakers of the session, if you could switch your camera back on again, and then we could start the session. We like yesterday, to all the visitors which are at the venue in China, because this year we are not only online, as you all know, we are online and at the same time have a large venue in China. And there is, so if anybody has a question to one of the speakers, just raise the hand and the microphone will come to you, or you go to the screen. So I will start with some questions which I got while we were talking. So the first question would be, when do you think an electric propulsion system, including propeller, batteries, and everything, for either an eVTOL or a fixed-wing aircraft Part 23 will be certified? We know that a Pipistrel certified system for an electric motor glider, but when do you think we will have certified propulsion systems with EASA or CAAC? Perhaps I ask the motor manufacturers first. Jakub, when do you think a full system in Part 23 or eVTOL could be certified?
Yeah, I think that this is going to be a question of the following 5 years, from my guess, yeah, and then from my perception of the situation, and also comparing it with the level where we are at. So this is my guess.
Okay, Matheu, what's your guess or your calculation, because you're planning?
Our planning is for certified EPUs, so electric propulsion units and batteries 2025. So when we look at the sort of the challenges of going from technology that is mature today, but into a robust product, and working with the regulatory bodies to take them through the safety cases, we believe 2025 is this very pragmatic date, and that is a challenging date for our engineers as well. We don't think we're slowing down when we say that date.
Okay, Liu, when does Wolong expect to have the first system certified? Probably first with CAAC, I suppose, in your case.
这个感谢您的问题啊。 这个因为您这个问题还是比较大，然后但是我们目前呢，我们卧龙布局还是在就是电机和电控这两方面，说这个这个问题还真不太好回答。然后可能目前截止到目前吧，我觉得我们目前可能还会是跟配合相关的主机厂进行整机取证，待可能3到5年这样，从技术的成熟度还有市场的成熟度，我们也会考虑就是单独电驱动系统这样的去取证。我的回答完毕。
Okay, thank you very much. And now back, Richard, as you work with many motor manufacturers with your propellers, what is your expectation? When do you think a full propulsion system can have a full certification, including propellers? Sure, because the propellers have to be certified in a certified aircraft as well.
I think maybe similar to Matheu, it will be 2025 in the EASA regulations. But my hope is that the small aviation, the microlight scene all over the world, but also in countries like Germany, will be maybe a bit faster. It depends how it develops. The permit to flies were given already now somehow. Even EASA, I think, will give them, as they know already a lot about their rules they would ask for. But talking about type certificate, I think it could be maybe in 2 years in the small light aviation. But it depends how it goes on. Some attempts are very close to fly somehow safe, and including a lot of rescue parameters, meaning parachute rescue system, and also security to fly without vertical elements that could help to enter this business earlier. And I think this way could be possible for the eVTOL scenery, but they would need to place bigger wing surfaces to make the sliding in homologated in certified aviation easier, because up to now the most trendy flying cars look like racing cars and not like realistic aerodynamic flying things which can also hover. So there's a wide spread between small and big, and also attempts to be based close to the sport flying and others based to automotive industry.
Okay, I have a question and a congratulations to Matheu, because right now, today, you talked about Vertical, and Vertical, I think, is going IPO, so they're going to the stock exchange today. And from the internet, we also know that Rolls-Royce is investor in Vertical, so congratulations there. So how do you see the development with Vertical, as it's also in your UK business, they are a UK business? Do you think UK can be one of the first ones having eVTOLs flying, perhaps with a Rolls-Royce propulsion system, or do you think probably the e-Commuter side will fly first?
Thank you, Willi. Absolutely right. And I think one of the most exciting things about Vertical, and it really echoes Richard's comments, is that Vertical is really taking a partnership approach with industry. So it's not only Rolls-Royce, it's Honeywell. There's many sort of organizations that are part of the kind of Vertical project to bring that aircraft through. That aggressive timelines, it's 2024, 2025 entry into service with customers that is trying, very clearly trying to be first. We think that gives a market advantage to the future customers, the airlines that want to operate the platform. And it is a differentiated platform in the noise profile and the range that it's trying to deliver. So we're really proud to be working with Vertical, bringing our, as a key customer, bringing our technology through. we think the whole UAM market is really exciting, and we're hoping to work with more UAM providers very, very soon as well.
Okay, thank you. Jakub, I have a question to you, which would be same to the commuter market, because you showed us on some slide the slides with the Vector EV55, where you're working on. This project, as I understand, is a research project for having a propulsion system replacing the PT6 turbine, which is one of the most used propulsion systems in this area around the world. Are there already other customers you're talking with who would use or want to use a PT6 replacement on the electric side?
Yes, Willi, the question goes straight to the point. Yes, there are, because this is our attitude towards the business in general. You know, if there are no customers, we cannot do it. You know, we're too small to be able to afford it. So yes, the question is, there are other customers, and we hope that we can deliver the system as we promised. Yeah.
Okay. I heard there is a question from the audience. I don't know how we manage this. Will you just speak with a microphone perhaps, or will the person come to the stage and speak at the stage? I think, yeah, I think the person is coming to the stage. So
可以听到吗？想问一下那个 Florian 教授。
So I have to switch on translation. So
想问一下那个 Florian 教授，就是国内的主机厂这边，您这边能提供一些什么样的合作方式或者技术支持吗？然后就是您有没有推荐的能够给国内的主机厂关于飞行控制这块儿，比较好的合作伙伴？就这个问题，谢谢。
So from when it comes to motors in China, I have to admit that I don't have a good overview, so I cannot recommend a motor manufacturer in China when it comes to flight control. I have been working over more than 10 years now with a guy called Wang Haimin, who collected a lot of experience in different companies in China. And he recently founded a company called Boundary AI. Please don't be distracted by the AI, because AI is nothing that I think is important for certified aircraft. But what I can tell about them, at least, is that they are very down to earth and they work very aerospace process oriented. So if it would be about a computer, flight control computer source in China, maybe they would be a partner to look at. And beyond that, it's of course good if you look at the domestic partners in China. But when it comes to motors and propellers, if you already have the computer from China, then maybe the motor can still be MGM and the propeller from Helix.
Okay, I think good answer. I have a question to Richard from Helix. I know that you work on a lot of different eVTOL, or with a lot of different eVTOL manufacturers. How many of them are that they say, okay, we are under NDA, don't talk about it? And how many are there which talk or publicly that they are working on this? Can you give a percentage? Let's say, okay, most of them want to be under the radar, or is it so that a lot of people just want to get the public and information?
I would judge 20 to 80. 20% they go to public, and 80% are not yet sure and want to try out their solutions with the possibility to stop project or to modify, mostly to get information. I think it is not in the way that the automotive industry all produce and try to find out, will a flying car be possible to manage? And they just want to find out to be sure about it. And this gives us many jobs. but of course they would not talk about their research and development to not make the customers or whoever nervous. But I'm very happy that we found it with Volocopter so far in the beginning. It is somehow the opposite, because they are blowing out everywhere what they do and how it is looking like, and try to show it in publicity. But nowadays, as I saw from Autoflight, it is good to bring these videos where realistic flying is visible into the public, but the majority does not.
Okay, next question would be considered to one subject we talked already yesterday a little bit, which is talking about like the supply chain management, because we all know up to now you normally has produced propellers, motors, everything in a relatively small numbers, and most of the aircraft it's more manufacturing still than it is a real serial production. So having this said, if you look at the things which are in the business plan of most of the eVTOL manufacturers, it's hundreds, thousands of vehicles they want to produce. Do you think in your field, in the propulsion system field, so I would start with Jakub, do you think you could manage also a serial production where somebody say, okay, I would like this and I want to have a VTOL, so I have to have 16 motors on one vehicle, and I want to produce 1,000 vehicles for the beginning. Would you be able to deliver such a demand? Because these are, I think, totally different quantities from what has been delivered in this field up to now.
Yes, really. Thanks for the question. The question is that it goes hand in hand also with enlarging our own capacities. Yeah, we have a project for brand new motor manufacturing and propulsion system in building, and also testing facilities. So it goes, if the question is, could you deliver 1,000 propulsion systems a year starting 2022 January? That would be very complicated. Yeah, no doubts about it. But it's highly, I would say, improbable that something like this is going to come. But we are improving ourselves and our capacities throughout the time to be able to deliver even a higher amount and for serial productions in about 3 to 5 years to get to much higher production capacity.
So same question to Matheu. You're muted, Matheu. You're muted. Okay, so same question to you. What does you think about the capability, serial production of larger quantities of propulsion systems, including batteries and everything? As we learned, you want to deliver the whole propulsion system if possible.
So it's a great question. So of course, in parallel with the technology and the product strategy, it's the industrialization strategy. So it's understanding the investment necessary, and of course, it's linked to the design regulatory approvals. You know, we need to be production approved organizations. We need to demonstrate the quality systems that are going to deliver safe, robust product through. So we've aligned internally our plans around that entry into service 2025. So we're looking to be able to produce our customer required volumes. You know, if you look at Vertical, and that you can look at their investor deck, it's publicly available. You know, they have a very aggressive ramp up. It's 50 aircraft first year, it's 250 aircraft second year, 1,000 aircraft the third, and you know, on each one of those aircraft we've got 8 propulsion systems. So you know, very first year we're very quickly ramping up into hundreds, then into thousands of units, and it is a challenge, but it's one that the automotive industry has demonstrated in the EV market for the past 10 years, and one that we, as an aerospace organization, are 100% focused on having to realize.
Okay, thank you. I already get the sign that we are in time, so perhaps quick answer also to the same question to Wolong. and then Richard, and what Florian, as he works with his institute together with a lot of manufacturers, what he knows about ramping up production. So first, Wolong, and with a question for a quick answer. Sorry, but time is always chasing us.
Sorry.
Shall I?
我没有太听清这个问题。就做我们就是我自己的 PPT 的总结是吧
？Sorry。Shall I repeat？
谢谢主任啊，也感谢各位专家啊，在这个整机的eVTOL上的这个电驱动系统的一个讨论，然后我们国内也会积极向国外的学习，然后共同进步啊，谢谢。
Okay, thank you. Richard, what do you think on ramping up for serial production? Because propellers sometimes are even more needed than motors, because you need more propellers in some cases.
Yes, but maybe similar to Matheu, it's clear that the industry can ramp up. It is shown in automotive industry, but breaking down to Helix, we are in the good situation that we produce already huge quantities, maybe from small propellers, but they are not so far away from the first one we need in big quantities. But we had the UAV challenge last year to ramp up 70% of our production capacity. And what I must agree is much more difficult is the quality management system. To bring up those big values into the market, quality management must increase. And we, as a traditional small company, had to fight hard to increase also this part. But from technology, the printing, composite is difficult, but it is easy to ramp up to whatever quantity. Nobody should fear about this issue.
Okay, thank you. Florian, you're muted. You're just a last word, and then we have to wrap up here.
We only work with serious partners with realistic ranges, payloads, and speeds. And therefore, basically, I completely agree with what Matheu and the others said about certification. So therefore, now it's first about flying. Then it's about certifying, and only then the ramp up will matter. And so our partners don't worry too much about the ramp up, also for the reason that they have realistic market expectations and don't expect the tens of thousands of vehicles immediately.
Okay, thank you very much. Thank you all for this very interesting discussion. Our next session will be on fixed wing electric.
How can you get eFlight Journal? Just scan the QR code on this page, or just type in your browser www.eflightjournal.com. Then you receive the page with the latest online news on electric flying, eVTOLs, and everything which is connected with electric mobility in the air. Or you can click the link on the top, and then you go to the latest PDF version, which you either can read in the Yumpu reader directly on your screen, like a conventional magazine, or you can go and download the magazine as PDF file so that you can read it offline wherever you want. Thanks for watching, and goodbye.